Hello everyone, welcome to the light microscopy lecture series. Today we'll be talking about the interactions of light when it touches or interacts with different sorts of medium. So how the behavior of light changes when it interacts with medium, right? So namely there are known interactions which can be broadly classified as you can see here. They're namely as absorption, reflection, refraction, diffraction, and dispersion. We'll be talking about each of these phenomena one by one. First, we'll be talking about absorption. For example, just imagine that how do you understand the color of a substance? Okay, or how our eyes perceive the color of a substance. So a very easy day-to-day life experience of everybody, we can connect with it, is when we see a substance is there, it is in the dark and there is no light falling onto it. Can we see? No, we cannot see because there is no light emitted by that sample or by that substance and it is reaching our eyes. No. Okay. Now, suppose if I torch a light, okay, I have a torch in my hand and I light it on that substance. And then you see that substance, the shape, size, of course, but also you see the color of that substance. Now, my question is, how do you understand or how do you know that color is suppose red or green? The easy example, if you say the first diagram, if you see here, suppose just assume the color of the substance is red. So when I light the torch gives out a white light, which is a mixture of all the colors of light, right? Now, when this light falls onto this substance by nature absorbs all the wavelengths except the color of the substance. I can see here this substance is red in color and it is absorbing all the other colors of light falling onto the sample, but it is not absorbing the color of the substance. So the red light is being reflected back from this substance, and when we are seeing this red light, we understand this substance is red in color. This is a common phenomenon of absorption, and that is how we see, like starting from a green leaf in which the rays of light falls, and there is a phenomenon of absorption, and it goes ahead with photosynthesis. Now, for example, you can see the other image. This substance is black in color. Now, as I was telling you right at the beginning, when there is an absence of light, it also looks black. We don't see anything. Now, suppose the property of the substance is such that whatever rays of light or whatever color of the light is falling onto that substance, it absorbs all the rays and it is not emitting or it is not reflecting any rays out of it. Then we will not be able to see any light coming out from the sample and the sample will appear black in nature. So if you talk of absorption, absorption is the phenomena of absorbing a particular color of light, and in cases of when you see the color of the substance, usually the color of the substance, the light of that color is being reflected and rest all the light is being absorbed by that substance. Okay. Now there is another phenomena where if you see in this case, the rays of light, all the colors, they are falling onto it and all the colors are coming out of it. So they are passing through this sample or through this material. But if you see the intensity of light before hitting this sample and then coming out from the sample has reduced. So the absorption of all the colors of light has taken place, but it has not absorbed completely. So on contrary to this black substance, which is absorbing all the wavelengths of light into itself and it's not emitting anything out. But in this case, what we see is, we see there is a reduction Okay. Now, if we consider another scenario where either one or other color of light is not being absorbed, or it is not the scenario where all the colors of the light is being completely absorbed. The third scenario is when uh, all the colors of the light is falling onto the sample and they are coming out of that sample. They are being reflected out of that sample, but the intensity of the incident light is higher and the light coming out from that sample has reduced. Okay. Now, in this case, in the third case also, we see the phenomena of absorption. Okay. But this absorption is not uh, compared to the first previous two cases. Here, the intensity is reduced because to certain extent, the absorption phenomena has taken for all the colors. So whatever rays of light or whatever color of light has fallen onto this sample, we see they have been absorbed to a certain extent. And that is why when we see the light coming out from the sample, the light intensity has reduced. So all these three cases are classic examples of absorption. Now, to brief it, absorption is a phenomena when a light falls onto that sample tends to absorb part of this light into itself and reflects a part of the light back. So in this case, what we see that either if it is in the color of the sample, that will be reflected, or it may not be dependent on the color of the sample, and all the right lights which is falling onto it is being reduced to some extent. Now, how can we capitalize this information in terms of optics or in terms when application comes to microscopy? So for example, I think all of you must correlate while working with a microscope, you must have used certain times some filters. And these filters, as you can see here, they're color-coded filters, basically blue, green, and yellow color filters. Now, these color filters, what they do is, so if you can easily correlate with the first example, in the first example you see here, if this is the color filter red, so it will allow only the red light to pass through it, and it is not allowing other color wavelengths to pass through it. So in the similar way, if it is for yellow, it is true for yellow, green, as well as for the blue. Now, there is another example where we saw the reduction in the light. So I think if a suitable example correlating with this is ND filter. So ND filter is basically, if you say elaborate it, it is a neutral density filter. This neutral density filter is placed either in front of the light source or near to the light source. Now, if you want to control the intensity of the incident light, which is supposed to fall onto your sample in the microscope, then usually a ND filter is placed in the light path, close to the light source. Now, you may also ask that there is an aperture control to the light source. Then why aren't we using an aperture control to control the intensity of the light? That's true. You can always do that. And there is also an aperture control always supplied with the light source, right? We'll be talking about different types of light source in my future lectures. But today, just briefly, every light source comes with the aperture control. Now, in spite of having an aperture control, why there is a requirement of having a ND filter or a neutral density filter? So if you can just imagine, an aperture control controls the aperture of the light path which is coming out. Okay. Now, either it will squeeze out, so either it will squeeze out the entire path or it will open the entire path. So if you close the aperture, the light at the center becomes brightest and the periphery becomes darker. So when you see the image, you have the brightest spot at the center of your image and your peripheries are somewhat dull in shape. But On the other hand, instead of controlling the aperture, if you place a neutral density filter. So a quick example, this is a broad daylight, and in the broad daylight, there is a lot of light, and in the light, you see the brightness is so high that you are not able to make differences, or there is no contrast generation, and we are missing the fine details. But just a ND filter placing there, you see the light intensity has been cut, and you can see there is a lot of contrast, and more details have come up, and that is why we are placing neutral density. And the biggest advantage is in neutral density filter, it doesn't no centralize or localize the sharpest brightest spot at the center. You see the entire filter is having the same intensity of light. So what it happens when the neutral density filter comes in the light path, there are several neutral density filters available in the market. You can have 5%, you can have 25%, you can have 50%. So based on the percentage of neutral density, it cuts off that much percent of light and allows the rest of it. So when this light is cut off or is being reduced, because you can see here by this phenomena, it's being reduced, but the intensity or has been reduced, but you do not see the light is brighter in the center. You do not have that problem. So when you get an image, you have an uniform illumination with a reduced light falling onto your sample. That is the advantage, and that is how neutral density has become very, very popular in microscopy to control the adjustment.